So as a continuation of discussion with the urinary system, things that you expect you to know, for example, now is what is the functional unit of the kidney? Okay, that is the nephron. And what is the nephron composed of? You have your Bowman's capsule, the proximal convoluted tubule, the collecting duct, and the distal convoluted tubule. One of the functions of the kidney is to get rid of or excrete this nitrogenous waste. If you don't have the ability to remove these nitrogenous waste, your bun level will be increased. Okay, uh, and we call that azotemia. So you have to need to know what azotemia is, but no clinical sign and symptom yet. When a person then have increase in bun, but having profuse sweating, diarrhea with vomiting, then they become uremic. And they could essentially, you have to bring this person to get the blood dialyzed. Otherwise, um, yeah, it's acting all weird today. I don't know why it does that. Um, okay, so hopefully the recording will work, and if you need to, you can listen to it later. I'm actually just reviewing what you already know. Things like uremia and azotemia, nitrogenous compound, okay, and um, the functional unit of the kidney is a nephron that is involved in making urine. And what are the three processes involved in the urine? We saw that is filtration, get is filtration, reabsorption, and secretion. And where does filtrations occur at the right here. Filtrations occurs right here. Okay, which is this area is known as the renal corpuscle, which the renal corpuscle composed of the Bowman's capsule that you see here and the glomerulus underneath. Okay, and the glomerulus has two blood vessels. The bigger one is known as the afferent arteriole that brings the blood into the glomerulus, and the blood drains from the glomerulus via the efferent or efferent arteriole. Okay, efferent arteriole, this one right here. And the hydrostatic pressure is what is needed to filter the blood. And when you filter the blood has to go through this thing here is known as the filtration membrane. What are the component of filtration membrane? Well, the endothelial layers of the glomerulus is one, the basement membrane is two, and the visceral layer of the Bowman's capsule that you see here. The visceral layers of the Bowman's capsule has these cells that look like foot cells, so we call them podocyte. Okay, and they have this little thing called pedicel, which is like finger-like projection, that interdigit, okay, the interdigit. And filtrates then passes through this membrane, and it's been collected in this capsular space, and then filtrate flows into this proximal convoluted tubule. So filtrations occur here first, and then at the proximal convoluted tubule, where you get reabsorption that takes back, like glucose and so forth. And then the filtrate continue on to go down to the descending loops of Henle, where the water will be removed because the loops of Henle oftentimes push into the medulla, and in the medulla there's a salinity gradient that is established, and then in the ascending loops of Henle, that's when the salt is being transported out into the medulla. So the loops of Henle function is to maintain that salinity gradients. We're going to see a little bit. Filtrate then flow into the distal convoluted tubule, and it's also surrounded by peritubular capillary, in which how drugs and creatinine, for example, can be secreted directly from the peritubular capillary into the distal convoluted tubule, DCT. Okay, and filtrates then, once the filtrate reaches the collecting duct, can be known as urine. So the question could be is, when is first urine is seen in collecting duct. The urine then flow from the collecting duct into the you can see here. All right, here. That doesn't really show you that well. Okay, here you can see. Okay, so all the collecting ducts are found here, okay, in medulla, that then dump into the renal papillae, which then drains it into the minor calyx, and two minor calyx or three calyx become major calyx, which then fuse all that into the renal pelvis and then down into the ureter, stores in the urinary bladder, and out the urethra. So the flow of urine you need to know as well, okay, the direction. We're talking about two different kinds of nephron. The nephron that is next to the medulla, known as the juxtamedullary nephron, and the nephron that is up here in the cortex, known as cortical nephron. One key difference, well, actually two key differences in the juxtamedullary nephron, which is this one, and cortical nephron, is that is in the cortical nephron, I asked you to remember how the blood flow into and out. So you remember them as RE, AIA, glomerulus, epiair, right? In the cortical nephron, the efferents arteria often give rise to the peritubular capillary. Okay? But associated with the juxtamedullary nephron, the efferents arteriole give rise to the vasa recta, which is actually goes into the medulla. That's one difference. The other difference is that in the juxtamedullary nephron, you can see the loops of Henle is much longer than the cortical nephron. Okay. This is just a gross anatomy of the kidney. As you can see, the minor calyx up there, minor, major calyx, renal pelvis, and ureter out, as you can see. All right. And here's to show you the key difference. Here will be your cortical nephron. Here's your juxtamedullary nephron. And you can see how in the cortical nephron, the efferents arteriole give rise to the peritubular capillary that you see here. These capillary network runs surrounding the tubule, hence the name, their peritubular capillary. Whereas in the juxtamedullary nephron, the efferents arteriole give rise to this straight blood vessel known as the vasa recta. In the cortical nephron, the loops of Henle is short. In juxtamedullary nephron, the loops of Henle is long. Okay. The easy ways to think of whether this is descending or ascending, and it's usually, you can just follow this. This will be the ascending loops of Henle. Now the ascending loops of Henle tend to be a little more thicker than the descending loops of Henle. So this will be the descending loops of Henle. This is the ascending loops of Henle. So the filtrate in the ascending loops of Henle goes into the distal convoluted tubule. That's this, right? And then this will go into distal convoluted tubule. Then it goes into the collecting duct, which is this. Okay. We'll come back to the significance of these. How does the loops of Henle able to maintain the salinity gradient? It's through this mechanism as countercurrent multiplier. All right. So filtrate flow, make sure you know them from the capsule, proximal convoluted tubule, nephron loop or loops of Henle, distal convoluted tubule, collecting duct. This is where urine started to see papillary duct, minor calyx, major calyx, renal pelvis, ureter, urinary bladder, where it's door, and then urethra. Another important thing to note is that now here you can see here's the renal corpuscle, right? And the difference between this shows you is the parietal layers, just nice squamous cell, but the inside the podiocyte, see this looks like it has foot extension, they're podiocyte, and so the podiocyte is what forms the visceral layers of the glomerulus. Okay, sorry, the visceral layers of the Bowman's capsule. Okay, and you have your basement membrane, and then you have your endothelium underneath. So that constituted the respiratory membrane. But to note here too is that once the filtrate have reached the proximal convoluted tubule here, then what you're going to see is that there's going to active transport, taking back of glucose and nutrients. And then once it's taken back, it goes into the peritubular capillary. But these cells is often involved in active transport, right? And so as active transport, you can see that these cells has a lot of mitochondria, okay? It just shows you that. And a lot of mitochondria, meaning that these cells require oxygens and nutrients to break down glucose completely to generate its ATP to involve in active transport. And so if there is a blockage in, say, renal artery or even the interlobar artery, then there won't be enough blood that goes to feed these cells of the proximal convoluted tubule. These cells will die. Right? So they're very extremely sensitive to oxygen level. If they become hypoxic, they could die. Right? Just like the cardiocyte, who get its oxygen to the coronary artery, coronary circulation. If there's a blockage in, say, left anterior descending, then the cells in the anterior left and right ventricle will die because they don't have enough oxygen it needs. Okay, and then when it dies, it actually will come part of the urine. It comes off and part collects in the urine, and we can look at the urine analysis to see if these cells die or not. All right, and you can also see in the cells of the distal convoluted tubule, you can see there doesn't have as much as mitochondria, but they do involve in some active transport as well. The key difference here, is that in the descending loops of Henle, you see how it's very thin. It thins so that it's very permeable for water. So water, in the filtrate, is in fact is leave because the surrounding has a lot of salt. Okay, and in the ascending loops of Henle, they tend to thicker there because now you see is that salt is being actively transported out into the ascending loop. As such, it's the loop that is important to maintain the salinity gradient. Now, if you move on to these down here in the collecting duct, you'll find there are two different kinds of cells. They're intercalating cells. These cells might be involved in exporting, say, some acid or base, but a lot of that cells actually is found up here. I'm going to show you a little bit at the distal convoluted tubule. There's an alpha cells and then there's a beta cells, which is actually secreting the acid. Okay. And the urinary system is the only system that can get rid of the hydrogen ion directly, whereas the respiratory system, it does it indirectly. Okay. Difference between cortical nephrons and juxtamedullary nephron. The cortical nephron, there's much more cortical nephron than it is in its juxtamedullary nephron. 85% relative to 15%. But it's this one right here that is involved in maintaining the salinity gradient. Okay. So please note that The loops of Henle help make the salinity gradient, and the greater the gradient, the greater the ability to concentrate urine. And note that there's two animals there. The beaver, who doesn't really need to conserve water, so the urine they produce has a lot of liquids in there, so they will have shorter loops of Henle. Whereas the desert kangaroo rat, for example, who needs to conserve water as his, main habitat is in the desert. So it would have a long loops of Henle, so then it will make a long salinity gradient. So then it can take back all of the fluid, the water from its urine. And so when it secrete concentrated urine. Okay. Blood supply that goes in. Note that the arcuate arteries and the arcuate vein is what separate the cortex from the medulla. Sorry, give me a second. I'm going to stop here.